beta decay, nuclear fission, atomic parity. Some of the most complex phenomena in modern physics. Breakthroughs that made the atom bomb possible and shattered the very laws we thought governed the universe. One of those so-called laws was the law of conservation of parity, essentially stating that if you flip something like a mirror, so left becomes right, everything in nature, like a chemical process, should stay the same. But in 1956, two men won the Nobel Prize for proving that law wrong. But actually, the person who actually proved it wrong wasn't a man at all. It was a woman. Dr. Chien-Shiung Wu. She changed nuclear physics forever. But when the Nobel was awarded, she was left out. She was called the First Lady of Physics. It's time we learn her story. Chien-Shiung Wu was born in 1912 in a small town near Shanghai, China. Her father, a revolutionary and advocate for women's rights, founded a school for girls so she could get an education. By 10, she left home to attend boarding school. By 18, she was studying physics at China's National Central University. But there was no nuclear physics program in China. In 1936, she, on her own, set sail for the US. And she made her way to the University of California, Berkeley. There, she dove into nuclear physics just as the field was exploding. Every physicist wanted to be the first to uncover the secrets of the atom. It was a golden age of discovery, and Chien-Shiung was right in the center of it. She specialized in beta decay, a mysterious process where unstable atoms eject particles in an attempt to stabilize. This changes the number of protons in the nucleus, which can even turn an atom into a completely different element. Then, in 1938, Lise Meitner uncovered nuclear fission across the pond in Europe. Chien-Shiung knew this would change everything. She became one of America's leading experts in fission, as well as beta decay and atomic structure. But being brilliant wasn't enough to get her a job. She was Chinese. She was a woman. And anti-Asian sentiment from the war was rising fast. She followed her husband to the East Coast in 1942, and she did get a job teaching at Smith College, a women's school, but with no research lab, which isn't ideal for an experimental researcher. Then came Princeton. She was offered a position during the war, not out of recognition, but out of necessity. With so many men away fighting, Princeton needed instructors. She was hired during the wartime faculty shortage. Princeton wouldn't allow women to enroll as students for another 26 years in 1968. Then, in 1944, Chien-Shiung was recruited to join the Manhattan Project. She was one of the few women allowed anywhere near the top tiers of this secret project, and was the only Chinese person on the team. Her presence alone challenged the norms of race and gender in wartime science, forcing colleagues to reckon with the mind they could neither ignore nor diminish. Her assignment? Solve the isotope problem. See, nuclear bombs are made with the element uranium. And uranium has multiple forms. Most aren't fissionable. Only a rare isotope, uranium-235, can sustain chain reactions. The additional step that's needed to create a weapon of mass destruction. Chien-Shiung's job was to help convert natural uranium into uranium-235. She spent years running experiments, refining techniques, and testing methods that would become essential to building the bomb. Then, in 1945, when the war ended, she returned to her research. She joined Columbia University and began testing a theory from 1933, one that no one had been able to prove. The theory said that during beta decay, atoms don't just spit out a random particle, they also release a specific invisible one to balance out the loss. But Chien-Shiung built the experiment, calibrated the instruments, and captured the evidence that confirmed the theory matched reality. A missing piece of atomic theory found at last. After showing that invisible particles explained beta decay, she took on an even stranger question. What if the laws of physics changed when you flipped the universe, like looking at it in a mirror? Well, first things first, why would anyone think to flip the universe? Because in physics, symmetry usually means stability. If you flip something, like your reflection in a mirror, most things still behave the same. This idea was called the law of conservation of parity. Think of it like raising your right hand, and your mirror image raises its left. Different directions, same motion, still balanced. It was comforting, elegant, treated as absolute fact, until it wasn't. In the 1950s, two theoretical physicists, Sung-Dao Lee and Chen-Ning Yang, started asking questions. What if parity didn't hold in every case? What if, during beta decay, those tiny particles didn't fly out equally in every direction? What if they all went mostly one way? It would mean something huge. The universe wasn't perfectly symmetrical after all. That nature does have preferences that defy the laws of physics and logic. That nature makes choices. They needed someone to figure out how to test it because they didn't know how. So they called Chien-Shiung. To take this job, she canceled her first trip back to China in 20 years. She spent 6 months designing a rigorous experiment. Then, just after Christmas in 1956, she proved it. Parity was not conserved. This finding shattered a core principle of physics. It was called one of the most important experiments of the century. And when the Nobel Prize was awarded in 1957 for the finding, it went to the two men who asked her to design and run the experiments. Chien-Shiung was left out. Again. And what's more, the Chinese Civil War had begun to unfold, and later, the Cultural Revolution. Remember, she had postponed her trip home to work on the parity project, and sadly, her parents were killed in the turmoil before she could plan another trip. She hadn't seen her family since boarding the ship to the US 2 decades before, and now it was too late. But her legacy, that didn't fade. In her lifetime, she earned the National Medal of Science and was the first living scientist to have an asteroid named after her. She was inducted into the National Women's Hall of Fame. And when she died in 1997, her story was still being written, because the discoveries she made, from how to build the bomb to nature still playing favorites, still shape physics today. Thank you, Dr. Chien-Shiung Wu, not just for proving theories, but for opening doors for those who would follow. Thank you for showing us that the impossible is only impossible until someone like you proves otherwise. Thank you for reminding us that the rules of the universe can always be challenged.